Hi, let's continue our discussion. To change things up slightly from our other lessons, I actually want to start incorporating some of the things that you might see if and when we take a region, some of the ways these questions might show up on some sort of a multiple choice assessment. So if you want to answer these on your own, go ahead, hit the pause button, take like 30 seconds to a minute. I'll give you a chance. If you didn't hit the pause button, we're just going to move forward. Looking at the first question on the left, we're looking for a mixture of three substances, and especially when it comes to this unit, there's a lot of code that takes place in chemistry. There's a lot of vocabulary. So substances, don't forget, that means element. Oh my God, I can't write an E. Element and compound, and we want a mixture, so not bonded, and we want three. So here we've got 1 and 2, and that's it, and 1 and 2, and 1 and 2, and 1, 2. So their answer there is 4. Which substance can be broken down by chemical means? This is again code for compound. And then again, you have to know that compound means greater than one element. Now looking at the answers, they're asking us to use the symbols, and we know that elements are capital letters. So we're looking for more than one capital letter, and that means that that's our answer. Similar to our first lesson, I just want to hit play, take a look. We're going to indicate how each of the pieces of paper have been changed. There we go. It's a bit of a long video, but I think it's worth the watch. So now we get to take a look at what they look like a little bit more close up. Sorry if that was a little loud. So there we have it. We've got two different kinds of changes. So we're going to write down really quickly. We had rip, crumple, soak, write on. What did we have? What were the other ones? We had eat and we had burn. So those are our 6 changes, ways to change a piece of paper. There are probably a couple others that we should mention once we get a little bit later, but classify them. Take a second, try and come up with some classifications. If I were to come up with some basis of classification, there's 2 main things that occur to me as a difference. Whether or not it was destroyed, right? Like that would be like the eat and the burn. Maybe the rip would count on as a destroyed or not destroyed. There's the ones that are, and that destroyed can mean an interesting, it can mean something interesting. We're going to say like destroyed maybe becomes new substance. We have the ones that are reversible or irreversible. And I think for today, focusing on this, whether or not it becomes a new substance. So destruction, it might be a strong word because our definition for today is physical and chemical changes. And for chemistry, these changes are defined at the atomic level. So for a chemical change, the atomic arrangement or structure changes. So in talking about destruction would be, this is why I'm saying it's a creation of a new substance. So the easiest chemical change on the list, I'm going to say, is burning. Now there's a question as to whether some of the other ones may or may not be chemical, but before we get to that, we should discuss what a physical change is by comparison. We're seeing something where the change occurs, but on the atomic level, everything is still put together the same way. So we would originally maybe say ripping or soaking. Those 2 would be the ones that I would most want to consider something that was destructive or changing. But it turns out that ripping, obviously a piece of paper ripped in half is still paper. So we're going to say rip and crumple. And yeah, soaking, it's adding water. But if we were to try and look at the chemical composition of the paper, I think what we would find is fibers of paper and molecules of water next to each other. When I add the water, it doesn't change how the paper is structured. Some of the properties, some of the things we observe might change, but that's not what we're talking about. So adding water, and don't forget, we said adding water is kind of like, aqueous means something. So that's making a mixture. Would be considered a physical change. Of the ones that are left, eating. That's 1, 2, 3, 4. Oh, and writing. So similar to soaking it, I think writing it is just introducing a new substance, but it doesn't change the paper. It just puts those dye particles right next to. And then finally, eating. So eating's a tough one because eating has multiple parts. I think the chewing is physical, but the digesting is chemical. So that kind of lines things up, whether or not it's becoming a new substance. And since it's an atomic level process, we should probably show what that means on the atomic level. That would be something like if we had a compound, it's going to change how these particles are put together, where you then have later something that's unbonded. Or even better, you have some arrangement like this, and then later a new compound is formed. The way it's put together is actually switched. And then for a physical change, what we're going to see is a few things are possible, but maybe something where you have particles arranged a certain way, and then at some later time, the particles are arranged a different way. You know, these guys are, oh, no, that's wrong. We're going to make that, that's supposed to be an open one. So I'm going to try and fix that really quick. Nope. There we go. That's a little more open. Don't want to split hairs over drawing. Oh, no, not the highlighter. I want the pen. Oh, still white. Sorry about that. There we go. So like the arrangement of them being very close together and then being somewhat farther apart. This, by extension, leads to something else we usually discuss along with it is physical and chemical properties. And these are things that we actually define based on our macroscopic observation. So this would be, the simplest way is that physical properties can be observed without changing composition. In other words, a physical property is the observation of a physical change, if that makes any sense. So when we're getting into these properties, though, there are some properties we haven't really spoken much about, like, color, we'll say this, color, mass, density, hardness. Those of you who took an earth science course at some point, these are our examples. And then chemical would then, by extension, be an observation that changes composition. And the best example of that would be how chemicals, substances react. So to say paper can burn, it has this potential to burn. Well, you can't really tell whether or not paper burns without burning it, and the act of burning it would turn it into something else. So the only way to assess the observation is to, in fact, destroy the chemical structure, the composition, how it's put together on the atomic level. There is one big thing that we should talk about in terms of summing things up, and that's a phase change. And in with this summary, we can also kind of touch on how it's represented in terms of symbols. A phase change, well, let's think about this. Let's look at the particles, because this may actually help. Is a phase change a physical change or a chemical change? So let's have our, sample solid. And we're going to melt it. And so then we've got the particles, and they're like, a little looser, they're floating around each other. I can't circle in, I'm bad at taking tests because I didn't draw in all of my symbols. That's in fact 7, so we're going to make 8 because I wasn't counting, and there was another one there. And then we could even go into the gas, and that would be this. To say that this was, say, element X, we'll give it that symbol. This would be in the solid phase, and this would be, well, it would be X still in the liquid phase, and then that final transition would be X in the gaseous phase. So notice that we're not changing the symbol, and because we're not changing the symbol, we're going to say phase changes are physical. And by extension, melting point and boiling point are also physical properties, which are defined as the temperature at which these processes happen. So for physical changes, we can expect to see that the particles don't change how they're put together. This is slightly misleading because I know the solid, they're very close to touching, but they're not quite bonded, so we'll get more into that later. Chemical changes, we're going to do a simple one here. Very basic chemistry. If we're calling these smaller particles hydrogen and these larger particles oxygen, and then we're turning them into, chemistry happens, insert sound effect here, explosion. If we were to write this out in paper, we would say this particle is H2, and this particle is O2, They are in a mixture, so we're going to put a plus. And there are 2 of these H2s, so I should put a 2 there. Don't forget that we're going to probably represent our phases here by putting that gas in parentheses. And then the arrow, and if we were to draw the end result, these particles would be labeled, well, there's 2 H's and an O. And there are 2 of them, so this would be 2H2O, and again, it would be a gas. So notice for the chemical changes, the particles are literally going from being connected to one particle to a different particle, and you can see in the symbology that we've gone from putting letters separate to letters together. The numbers, the subscripts can actually change, and all of this is an indication that chemistry is happening, a chemical change has occurred, and that we are observing a chemical property. Thanks for watching.